get as much detail as possible. Okay. All right, so Joseph and Renee are standing at the seashore 10 miles apart. The coastline is a straight line between them. Both can see the same ship in the water. The angle between the coastline and the line between the ships is 35 degrees. The angle between the coastline and line between the ships is 45 degrees. How far is the ship from Joseph? So we're trying to find X. Is that right?
I think so, yeah.
Okay. And these are, are you doing, I assume you're doing law of sines, law of cosines?
Yeah.
Does that seem right? Okay. All right, so X is across from 45.
Yeah.
So the setup here is you're going to either put the length or the angle on the top or bottom. Okay, but you got to be consistent here. So if you put the length on top, you have to put another length on top here. So the only other length we have is 10, and then we need the angle across from it. So it you might not think that you've got that, but the three angles have to add up to 180. So 35 plus 45 plus this missing angle has to equal 180. So the missing angle is 100 degrees.
Oh, okay.
So to solve law of sines, you're solving a proportion.
So X over sine 45. Okay.
So you're gonna
multiply or no?
You actually just multiply the sine 45. Like you don't have to multiply by X because you're trying to get X by itself. It's already in the top left. So X equals 10 sine 45 over sine 100. And make sure your calculator is in degrees for this calculation. So 10 times sine 45 over sine 100, and you get 7.18 miles.
That seems reasonable too.
It is, and they could just as well ask you for y. Y is the other distance, but they don't. Okay, can we move on to B? Or sorry, part number 2?
Let's go for it.
All right, number 2. Airplane A is flying towards the airport, which is 20 miles away. The pilot notices airplane B is 45 degrees to her right. Airplane B is also flying directly towards the airport. How far is plane B from the airport? So we got to find X. So X is across from 45. 50 degrees is across from 20. So like law of sines is written this way: A over sine A equals B over sine B equals C over sine C. And you can use it in such a way where you can choose 2 of the 3 to set equal. But essentially, you always need an angle and a side pair, an angle and a side pair. So you're trying to find X over sine 45. And then the other length here is 20. That goes up top over sine 50. So just like the last problem, you're solving for X. To do that, you're going to clear out the sine 45. So it's 20 sine 45 over sine 50. So I get 18.46 miles.
Yeah, that's correct.
All right, number 3. Did you only get 4? Oh, these are really fast. A lot of times they want you to solve for the whole triangle, but your instructor is being very gracious with you, only asking for a little bit of information. So the scenario really doesn't matter. Like I read this as blah blah blah. Here's some information about the triangle, and you're trying to find AB, and AB is x. So do we have the angle across from x? Yes. So we know that x over sine 15.33 equals this other length 354 over, well, we need this angle down here. Do we have angle A? No. But we know that 112.17 plus 15.33 plus angle A equals 180. So we can solve for angle A. So 5, 17.5. So what is that, 62.5 degrees?
Yeah, there we go.
Is that what you got?
I add them up, I get what is it? 127.5.
Oh, that's right. That's right. So it's 52.5. 52.5 degrees. So that's what goes up here in this position. And then x, when you solve for x, x is 354 sine 15.33 over sine 52.5. Let's see what that is. So we got 354. All right, I got 1181 meters.
Okay.
It's not drawn to scale, so this is actually more of an obtuse angle right here. This 112 is pretty obtuse, and then this 15.33 is pretty sharp. So
Yeah, it doesn't.
I don't
It's
know.
not proportional at all.
Yeah, it doesn't look right at all, but the number is reasonable, I guess. All right, let's move on to number 4. Got a helium balloon problem here. Why didn't that snip in? Oh yeah, that's why. There's this odd thing that happens when you copy from Google Docs. You have to snip them instead. Okay. Large helium balloon. There's our helium balloon. It's tethered to the ground by 2 taut lines. So sometimes they don't give you the information. I guess like you have to fill these in. So one line is 100 feet long and makes an 80-degree angle with the ground. Second line makes a 40-degree angle with the ground. How long is the second line? So we have to find x, and then how far apart are the tethers? So you gotta find both of these
The
values.
X and Y.
Yeah. So 40 though is across from 100, so we know we're going to use that. X is across from the 80, so we're going to use that. X over sine 80 equals 100 over sine 40. I'm surprised you didn't get one where you had to solve for the angles. It's a bit. Usually they give you both. In
Yeah, it's up
this.
there too.
So x is equal to 100 sine 80 over sine 40.
This wasn't all that I wanted to go over. I just kind of wanted to go through this and then just go through a couple of physics problems.
Okay, sounds good. So this is 153.2 feet. And to find y, we need to know this missing angle here.
Okay.
So the missing angle is 60 degrees because these three have to add up to 180. So you got y over sine 60 equals, now you have your choice here. You can either use the 100 over sine 40 or x over 80. I recommend using the known angles or the known sides and angles rather than the calculated ones in case you made a mistake.
That keeps it from being incorrect.
Yeah, but you're doing your best to avoid that. So it's 100 sine 60 over sine 40. So 134.73 feet.
From a glass, that's pretty reasonable. This one's actually proportional compared to the last one. Alrighty, so we're done with that. I'm gonna do some physics problems. I just kind of want to get a head start on my stuff.
Okay.
Alright, let's have the first problem.
All right, let me check that out. There it is. Okay, so some screenshots here. Oh, okay, so we got this stuff again. All right, the Dario, a prep cook, spins a salad spinner and observes that it rotates at a constant speed 20 times in 5 seconds, then stops spinning it. The salad spinner rotates 6 more times before it comes to rest. Since the spinner slows down with constant angular acceleration, what is the magnitude of the angular acceleration of the salad spinner as it slows down? So we're trying to find alpha. Alpha is analogous to A. Um, alpha is the change in W over the change in time. W is the change in angle over the change in time. Maybe you saw those equations at
Yeah, I
some
have.
point. Sorry, that was not what I wanted to do. Okay, screen back up. Okay, I gotta find a reference here because it's been a while since I've done these. Make sure you get you the right answer. So we're trying to figure out the angular acceleration.
Yeah.
Let's see what we got here. All right, so the 20 times in 5 seconds. All right, so the solid spinner rotates constant speed. Okay, so the angles that it goes, the amount of angles that it rotates. So this thing is spinning, over and over and over and over again. The angle it rotates is 20 times 2 pi. So that gets you to 40 pi radians.
Why just 40 pi radians?
Well, but the angular velocity W.
Yeah.
W is the change in the angle over the change in time. So the change in angle is 40 pi, but it does this in 5 seconds.
Yeah.
So that's 8 pi radians rads per second. Okay. So that's does it ask for that? What does it ask for? It asks for the angular acceleration. So we're getting to that point.
The one where it slows down. Yeah.
Yeah. So the angular acceleration is alpha is equal to the change in W over, well, I don't know where they come up with this equation, frankly. It's minus omega squared over 2 theta. So the angular acceleration here, right? I'm sorry, the angular um, acceleration is the change in W, which is 8 pi squared over 2 times however far it went. And so the last six, it rotates 6 more times. So that is 6 times 2 pi. So it spins a bunch of times, and then later on it just spins 6 times.
Okay.
So that's where this other one comes from. Yeah. So the calculation here is putting this in my calculator. You get minus 8.38. But since it wants the magnitude, it's just 8.38 radians per second squared.
That's right. How long does it take for the solid spinner to come to rest? That's what it's asking for now.
That's what it's asking for now. Part B.
Yes.
Okay, so the amount of time it takes for it to slow down and come back to rest. I think it wants you to use the So we're going to use the equation. Okay, so the analogous equation here, this is what's maybe unclear, is v final equals v initial plus acceleration times time. That's from 1D motion. So here it's omega final equals omega initial plus alpha times t in rotation. So we're solving for t. The omega initial is what we had calculated up here in 8 pi radians. The omega final, it comes to rest. That's 0. So we've got 0 equals 8 pi plus alpha. That's the minus 8.38 t. And we're just solving for t. So t is equal to negative 8 pi over negative 8.38. Negative 8 times pi over 0.38. So it's about 3 seconds.
All right, that worked.
What do you want to work on next?
Just one more problem. I'm going to send it to you.
Great. So I should have said like what we're doing now is like you have x of t equals 1/2. Well, let me do it the other way. You do it this way in this class. X naught plus v naught t plus 1/2 at squared. So in the analogous equation here is theta of t equals theta 0 plus omega 0 t plus 1/2 alpha t squared. Then you've got v of t equals v0 plus 2 at. So here you've got omega of t equals omega 0 plus 2 alpha t. And the equation that I should have been more clear on, you have some other ones. You have like v final squared minus v initial squared equals 2at. So that the analogous over here is omega final squared minus omega initial squared equals 2 alpha t. They line up really well with 1D motion. Okay, so I see another question here's come in. And
Today.
All right. Very thin circular hoop of mass m and radius r rolls without slipping down a ramp inclined at an angle theta with the horizontal as shown in the figure. Okay, great. There it is. What is the acceleration a of the center of the loop? We're doing this in terms of all these other variables. Great. Okay. I definitely gotta look this one up. I don't even know where to start on this. A very thin I'm looking for something with a picture because I think this is kind of unclear without seeing that. What are we solving for? The acceleration? Yeah. Okay, so let me grab the picture here. Okay, so here's the picture. So in the x direction, it says that there's force of friction mg sine theta. So they're saying that from here there's an mg sine theta. Like there's normally this and this. So the theta is there. and mg sine theta. Okay, so in the x direction is mg sine theta. There's friction going this direction. They just call that F because it opposes motion. So if you're following me right now so far, then we'll call the right, because we'll call the direction of motion positive. We have mg sine theta minus F equals ma. Is that okay?
Yeah, that's okay.
Okay. Now they tell you that the torque is only due to friction. I guess you're studying torque now, and they tell you that the torque is I times alpha. Maybe you saw that in class, I times alpha.
Yeah.
Well, the I for a hoop, the I for a hoop is 2/3 mr squared. And the alpha here, alpha is equal to A over R. So this is A over R. And this is all equal to force times radius. Yeah, FR. So this equation right here, you can see that a lot of things cancel. Like this R squared cancels with this R. So you get 2/3 MRA equals FR, and the R's cancel, so you get F equals 2/3 MA. So this goes into the equation here. So we have mg sine theta minus 2/3 MA, I'm sorry, yeah, equals MA. And we're solving for A. So we can add this term to the other side. This is really 3 over 3. So you get mg sine theta equals 5/3 MA. The m's cancel because they're on both sides. So A, if you clear the fraction, it's 3/5 g sine theta. That's your answer for that one.
Sounds good.
Did the answer work out?
I'm still trying to put it in right now.
Okay.
This one would say it was incorrect. It said your answer either contains an incorrect numerical multiplier or is missing one.
Oh man, let's see here. 3/5 g sine theta. Let's see what else. So a lot of these just have the answers, which didn't seem very helpful. This one was 0.5 g sine theta. Maybe I used the wrong formula for I. That's the only place that could have created a problem. This I up here. Let me see what this one. Yeah, this one. So the ones I'm seeing now are 1/2, 1/2. Why isn't this entering? Okay, 1/2 g sine theta. Let me look at why they do that. So they use I of the hoop as, what do they use for I? Their I is mr squared. So they don't have this coefficient in front. So that removes that. Okay, so that's why you end up getting a 2 here, and then you divide and get 1/2 g sine theta. So there's a bunch of different eyes for different objects. There's eyes for hoops, spheres, I don't know, cylinders, and then there's ones like if it's a sphere but it's hollow, hoop but it's hollow, cylinder and it's hollow. There's a bunch of these.
All right. I think that was everything I wanted to go over today. Thank you,
Excellent.
Matthew.
Thanks so much for scheduling, and see you next time.
See you. Goodbye.
Bye.